This for children on the web can see this expanded. Oh boy, here we go. Okay. Oh, I forgot that. Don't forget the y. 6 x y squared minus y cubed. Hey, go ahead and check your work up here when you're ready. I think I didn't screw that up. Did I get it right? You got it right? Yeah, I'll give you a stick. Okay. On where would expansion of binomials be useful? It's kind of just a nice trick to have in your back pocket. But once you get the hang of it and you know Pascal's triangle, which you can easily construct, I had honors pre-calc kids say, "Are you going to give me Pascal's triangle?" I said, "Can you add numbers?" They said, "Yes," sometimes. And so Pascal's triangle, of course, I wouldn't take this to like the 20th power because that would take you forever to write all that out. But it's useful up to a reasonable. It's only useful when it's useful, right? Just like slope fields. Okay, so it's a good trick to have in your back pocket and to use when necessary. Okay, what's due tomorrow? Benchmark 1, okay? Benchmark 1 is due tomorrow. You got to have your topic selected, an opening paragraph, and some math. And I want it typed. Okay, I want it typed. I don't want this chicken scratch handwriting that some of you have. I'll create a Dropbox if you want to drop it electronically. How about that? If you don't want to print it, I'll make a Dropbox. Okay. More information on that. Your stimuli, seed list, and some other information. Okay, I do want to talk real quick. Okay, finally, let's get into the math. We're going to talk modulus and arguments. Do you know how to do the arctangent of an angle or of a ratio? Do you know how to use arctangent to find an angle? Yeah. If you know the unit circle well enough, do you even need arctangent? No. If you know the ratio of two sides falls in the unit circle or is related to the unit circle, you can find that angle without a calculator. Okay. In some cases, you may not have a ratio of sides that's unit circle worthy, if you will, right? It can't be scaled to be in the unit circle. So then we might have to use a calculator. Example, I'm going to get to this stuff in a second here. But let's say we have an angle in the first quadrant, and it looks like this, and I got a, I don't know, a 1, a root 3, and a 2. You would say theta is pi over 3, right? Okay, so let's say we have a 1 and a 1. Pi over 4 would be the angle or argument. What if I had 5 and 12? Well, I don't know what that is, right? But it's an easy solve. If I want to find theta, I just take and I write out my ratio in this form, and therefore theta would be the inverse tangents of 12 over 5. Calculator does the work. Make sure you're in radian mode. Blah. Done. Right? Okay. That's no different if it's in the complex plane. This point would be the point 5, 12i. Right? 5 plus 12i. No difference there. Okay. So what would the hypotenuse be here? 13. Good. So if we call z, we call this complex number 5 plus 12i. 13 is called the modulus of z. That's the modulus. That's the modulus of z. Will somebody with a calculator do the inverse tangent of 12/5, please? It's like 57 something, I think. Okay, so in radians, we see that theta is 1.176 radians. Okay, so what we've done here is we've found the arguments. Here's the argument, and here's the modulus. What does that tell us? That tells us the radius of the circle that triangle would be in, or the hypotenuse of the triangle, and the angle of rotation. So let's say that I take some, I don't know, let me test your polar abilities here. Okay, let's go let's go 5 cis negative 3 pi over 4. Will you plot that for me? Let's see here. That would end up in which quadrant? Third quadrant, right? I'd have 5 here. What would this angle be? Yeah, pi over 4, right? So the angle of rotation is negative 3 pi over 4. And I get a hypotenuse of 5. Well, that tells me that this must be 5 over root 2. And this must be 5 over root 2. But they're both negative, right, in the third quadrant. And therefore, this point z, which is a complex number, right? How do I know this is going to be a complex number? Because it's cis. If I had written this, then we know it's real. That's real. The other one's cis, therefore it's complex. So this point would be negative 5 over root 2 minus 5I over root 2. Minus, right, in the third quadrant. It's left, it's down. Third quadrant. Cool. Make up. Okay, sketch that, please. Sketch that. And write that in rectangular form. Sketch that, write it in rectangular form. In 4, right? 7 pi over 4 is just short of 8 pi over 4, which is 2 pi, right? Yeah, I'll go with it for a second. Okay. How do we feel about that? Pretty good? Yeah.
If the modular equal to 1, would it be 2 over the square root of 2, or would it be just 1 over 2?
No. Well, yes, actually it is. Here's a varsity version, right? If you rationalize the denominator, I'd multiply bottom and top by root 2, and then those 2's would go away, and I'd get root 6 minus, what would that be? I root 6. And that makes sense, right? When you look at anything in rectangular form, if you have 5 minus 5i, you know that's going to be an argument of 45 of some sort, right? It's going to have a pi over 4 involved. And look at that, I've got a root 6 and a minus root 6, puts me in the fourth quadrant. Now, one thing that I want to highlight here is that the argument the argument will always, we want the argument always within these bounds. Okay, we always want the argument between negative pi and pi. Always. Okay, it just keeps the calculations simple later on down the line. Okay. There are a few properties that can help you. For example, if I were to find the argument of z squared over w cubed, I would utilize a couple of these properties. First of all, I wouldn't square z first. Okay, like this is saying it'd be the argument. What I would take is the argument of, instead of z squared over w cubed, I'd take 2 times the argument of z over 3 times the argument of w. Now, what does that even mean? Well, somebody give me those values for what is z and what is w.
Z is 2 minus I. W is negative root 5 plus I.
Negative root 5 plus I. Okay, so I'm just going to sketch these real quick, and you can kind of see how my thinking works. Which quadrant would this be in? Fourth, right? I would sketch it like this. I'd go over 2 and down 1. Okay, and I want that argument. Well, in order to get that argument, I would take, theta would be the inverse tangent of negative 1 over 2. Okay, agreed? So this would be the argument of z. But I want the argument of z squared up here, which I would just take 2 times the argument of z. So I'm going to take 2 times whatever this is. Somebody do that calculation quick for me. Okay, and then over here, w, I'm going to locate this. This is in the second quadrant, I believe. So I'm going to go left root 5 and up 1. I don't even need to know the modulus. I don't care about it, actually. I just want this angle right here. So I would take the inverse tangent for this of 1 over negative root 5, get a value, and multiply that by 3. Why? Because I wanted the argument of w cubed. It's just a property. It's kind of like logs. You can take that exponent, bring it down in front as a coefficient. Did somebody get inverse tangent of negative 1/2?
Negative 0.46.
Okay, I'm okay with that. And then somebody inverse tangent of 1 over negative root 5.
Negative 0.421.
Okay, and if I want this, if I want the argument of z squared over w cubed, I'm just going to take the argument of z squared over the argument of w cubed, which would be whatever that is, negative, let's just leave it in this form, over negative this. And I'd have my angle. Now, that's hard for you to comprehend. What does that even mean? Like, what does that look like? Well, that's the angle. If I took this to the second power over that to the third power, that'd be the angle of that new complex number. That's all, right? It'll come out to be a positive, so we know, we don't know a whole lot because we'd have to then isolate what quadrant it would be in, but that's how you do it. Okay, so let's do a couple practical homework questions here. Recall that quadrant 1 is positive, positive, and then all the way around the unit circle. We already talked a little bit about this, but let's put these into polar form. Express this in polar form. Well, what would that look like? That would be y equals some number cis some angle. Let's talk through that for a moment. What would that number, what would the modulus be? We're going to use Pythagorean theorem. What's 2 squared? 4. What's 3 squared? 9. So it'd be the square root of 13, right? So that'd be the square root of 13. And then if I were just to sketch that point, that polar point, or that rectangular point, I'd be right 2 down 3. So over 2 and down 3. That's not unit circle recognizable for me, so I would take the inverse tangent of negative 3 over 2. And that would give me my argument. Not sure. Luca, can you do that for me? Okay, so negative 0.98. Okay, so close to negative 1 radians, which would be in the fourth quadrant, obviously. So that would be our argument right there, theta. Okay, argument and modulus. Why don't you take a moment with a neighbor and do what we've just done a couple of times and put that into Cartesian form, which is just rectangular. Do that with a neighbor. We'll take 2 minutes to do that, and then we'll talk through maybe a couple homework problems. What does the 5 mean here in polar form? Extend out 5, right? And then rotate how much? 3 pi over 4. So that puts me in quadrant 2. So I extend out 5, imagine that, and then rotate to there. Well, if I have a pi over 4 involved, that means this is going to be a 45, 45, 90. If the modulus is 5, then what do I do to get the legs? Divide by root 2. All you got to do is divide by root 2. Okay, oops, I did that part wrong now. The imaginary portion is always the y-axis. So I'd have a negative. So this point, which I would, in complex form, in the rectangular form of that, I would write like this. And there's another form you could write this in. But that would be acceptable. Okay? Or 5 root 2 over 2 in both of those. Yes, sir. Let's keep rolling. Let's do a homework problem here. You're going to have to get used to like identifying some tangent angles. And one way that I like to do it, I mean, there are obvious ones like inverse tangent of an undefined value is going to be at pi over 2. Inverse tangent of 0 just means the opposite side is 0 over the adjacent side, which would be 1, which means that this would be 0 pi or any or any pi value for that matter. So that'd be 0 pi or 2 pi, etc. Inverse tangent of 1. What angle would give me a tangent of 1? Any pi over 4, right? So I'm thinking pi over 4. Where would the opposite side, in which special triangle, where would the opposite side be smaller than the adjacent side? Pi over 6, correct? And where would the adjacent side be smaller than the opposite? Pi over 3. Square root of 3 is larger than 1. It is larger than 1, right? Everybody agrees with that. Therefore, those are some angles just to be aware of. This is extra practice along here that you can do on your own, but I want to look at some homework. Calvin. Okay. Finding the modulus and argument for each of the following. The only way you could find the modulus and argument is if you have a complex number that is written in this form. So these two I'm going to have to adapt by multiplying by what is our favorite thing that old people love, the conjugate. Let's do one of them. How about part C? Let's multiply top and bottom times 1 minus I. So bottom would be nice. That's 1 times 1 plus I times negative I. Well, that'd be 1 minus I squared. And what will that be equal to? 2. Good. And then if I FOIL the top, I'll get 1, and then I'll get minus 2I, and then I'll get plus I squared. So it looks like I get negative 2I over 2, which is equal to negative I. Where is negative I located if I... Do I go left and right at all? No. There's no real portion, so it's just down 1 unit. What would the modulus of that be? 1. So the modulus would be 1. What would the angle or the argument be? Negative pi over 2. Right? You can say 3 pi over 2, but that's JV because we're always between negative pi and pi. Right? So make sure you're aware of that. That started a couple slides ago, but that's okay. Okay, so that would be our modulus and argument. Anything that ends up on one of the axes is called a quadrantal. Yeah, it's called a quadrantal. Yeah. Let's try another one. Express the following in polar form. Oh, unit circle. Hello. Unit circle. Let's do H. Let's do H. Just for Heidi. Okay. Which quadrant are we in? 4. Good. 1/2 over here. Negative root 3 over 2 over here. Please tell me you all know what the modulus will be. 1. Good. Modulus 1. Modulus will equal 1. That's unit circle. That's our life. Argument. Argument. Negative what? Pi over 3. Good. There we go. This should be cash money in the bank. Free chicken. Free chicken. Okay. Express the following in Cartesian form. Just rectangular. Okay. Let me show you how I live this life. I already know 4th quadrant. I know quadrant 4 right there. Negative pi over 4 is right here. And this is root 2. What would those be? 1 and 1, yeah. Well, 1 and negative 1. So this point would be 1 minus I. Done. 1 minus I. Yes, Wyatt. Okay, this is a Mark Wahlberg snipe. Someone's going to get sniped here. Mr. Ludd, you said that R would always be positive. I lied a little bit. Did I? Did I say that or just think it? It's okay if R is negative, our modulus is negative. What does that mean? It extends out left instead of right. So extend out left. If I extend out left and then rotate negative pi over 3, will I go clockwise or counterclockwise? Okay, so here, let's just, if I put this down, right? Would you be okay with the fact that I extended out 8 and then I rotated this way? Okay. If I have a negative 8, that just means I extend out to the left and then I still rotate clockwise. Negative angles rotate clockwise. So that puts me here. I have a value of 8. Now this is where your 30, 60, 90 properties, if you don't remember those or didn't get the tattoo, okay? If this is a 60 or pi over 3, and this is a pi over 6, the short leg is what fraction of the hypotenuse? Half. And then multiply this by what to get the long leg? Square root of 3 over 2. Or square root of 3, sorry. So our Cartesian form of this point right here, we'll call this point Z, is going to be negative 4 plus 4I root 3. Cartesian is just rectangular. Complex can be either rectangular or polar. Okay, I'm verified, so it doesn't matter how long I go. But I did have to give up my offshore bank account information, which isn't that much anyways, just a couple commas. Argument. Oh, that's cute. There's people having an argument. Hey, one nice little shortcut here for C, and then I'll leave you alone, is to find the modulus of Z and then just multiply it by the modulus of W. That's just Pythagorean theorem. What's 1 squared plus 1 squared? 2. So the modulus of Z is the square root of 2. What's the modulus of W? Square root of 4, right? Negative 1 squared plus square root of 3 squared. Square root of that would be the modulus of W. So it'd be the square root of 4, which is 2. Oh, so the modulus of Z times W is 2 root 2. It's 2 root 2. Yeah, I know, you're impressed. You're like, wow, you spent all weekend doing this? I was like, no. I pretty much made sure my dog didn't eat another dozen crayons like he did the other day.